Hello. So today I'm going to be having a discussion about Atcoder problems from 1 to D. So the first problem was if you have been given a head and you've been given a body. So it has to make sure that must be less than equals to h. If it is not, then you need to add some x to it so that it is equal so that the body does not tip over. So it is exactly sure that you need to add the minimum amount so that the robot does not roll over. So that minimum amount would be h minus b. Now what we can do is like we can have this common and be like n to 0 1 ln, because if it is negative, that means the body is already not tipping over. So yes, I don't think that I need to code this, so I'm just going to the next task. So next task is robot. So you have been given weight of the robot is x, initial weight of robot, and then you have been given n types of robots. So and then you have n types of parts you have been given, and then you have been given q queries. So for each query, you will need to see for each query, you will get some number like 1, 4, 1, 2, 3. So, and you need to see if this part was already attached, then you detach it and then print the sum. So basically initial weight was x. So if what we can do is like create a map in which we'll store if this part has been stored or not. So if map dot find the index which is 1, then what you will do is x minus is equals to uh, arr of I, in which we are inputting these numbers. So x minus that, and otherwise if it is not found, then you will insert in the map and do an addition. Let's see the submission for this. Mhm. Hmm. So yeah, basically I've taken an input for the array, and then in the map I will show the index of the elements that are being taken, because that is what makes sense. So if it is not found, then if it is found, then x minus equals to air of p and mp dot erase p. Otherwise, 2x plus equals to air of p and mp of p is equals to air of p, and then see out x. Yeah, this was very simple. Now we move on to the third task. So third task is that you have been given n heads and you have been given some m body parts. N is head and m is body. Now you need to make k robots out of it, such that for each h of I must be less than or equals to b of j. So this is pretty straightforward again. So what you can do is like you have been given the array. Acha, you also have given, if you can make k robots, you need to print yes, otherwise you need to print no. Okay, so let's say that you have been given some h 1, 4, 5, 8, 6 and 2, and then the body parts are given like 1, 2, 4, 3, 7 and 9. What we can do is like we can just sort both of these, so that for each and then start from the last element. uh, why? Because if you start from the last element and then you try to find the element which is, so now let's just sort this. So 1, 2, 3, 4, 7, 9. So for 9 you will try to find if there exists a body which is if there ex for, if there exists a head which is, and also sort this. So 1, 2, 4, 5, 6, 8. So if there exists a head which is less than equals to weight of body, if there exists, then you do count plus plus and then decrease this and decrease this. Otherwise, if you have again 7 is less than 6, so again it is possible. Now you have 4 and head is 5. So 4 is greater than 4 is less than 5. So you'll move on and then not do a count plus plus, and then when you find something like 4, and then you'll do a count plus plus and then decrease it again. So now you have 3, and then you have what do we have? I think this is 2. So then again it is possible. So yeah, so like this way you can do and then try to find the count. Let's see the submissions. I did have some wrong in this because what I was, let me show you my code. So basically, what I was doing was like I did sort, but what I was doing was I did not do this. Like I took the map not needed. So if j is less than equal 0, then break. Then I'm iterating over all the bodies and trying to find if there exists a head which is less than, which must be, until unless condition is true, we'll do j minus minus. As soon as you find a j, then you do mp of I is equal to j and count plus plus. Now this part is important, to j minus minus again, because if you don't, then let's say that you uh, find some head which is less than equals to body of j, and then what can happen is like it can go on for multiple times because this condition is always true. So now we are not decrementing j at all. So after you do this, then it will make sense. And then see, then the map just inserting that for each like the pair of I and j, like this is the possible pair. And then for just check the map size. If it is getting equals to k, then print yes, otherwise print no. Okay. Now the next problem. So this problem was interesting. So basically, you have been given a robot. A robot has n types of parts attached to it, and then you have weight of the part, if it is being used as a head or if it is used being as a body. All right, some wi. Now, what we need to do is like we need to create a robot which can have any number of bodies. It may or may not have a head, but any combination of sigma I is equals to 1 to k of for each, um, and then you also need to create like a head, so such that this must be greater than or equals to sigma some x elements. If we are taking of each h of j, then this must hold true. So basically what he is trying to say is कि मान लो कि तुम्हें you have been given uh, you need to make a robot in which you have to choose if you want to choose this as a head or a body. Okay, so now yeah, right. So basically you will either in the example, let's see, so 141 and 59, and then you have 2 65 35, and then 8 97 and 93. So if this part is being used as a head, then so if I'm using this part, I can only use one of the parts. So ऐसा नहीं हो सकता है कि I am using 65 as well as 35. So what I can do is I just use anything. So now let's say that I choose I will make a head out of this portion and body out of the other two, because head, anyway the combination of head and body must be taken, but it also must be taken into consideration that the sum of head, uh, sum of the weight of the because each part is also contributing to its happiness. So happiness score is like HI or BI. Now लेकिन वो जो combination of parts I'm taking, उसका weight of all heads must be less than equals to weight of all body. Now let's say I'm taking this, so weight of as a body. So now this is 1, and then I'm taking again this is a body, so 1 plus 8. And also I'll take the maximum of these two, so 93 plus 59, and then I'll choose 2. So this is greater than or equals to 2, which is true, and then for I can choose so this is header and this is body, so I'll choose head, which is 65. So what does this total into? So 399 is head and then 65. So let's do a calculator. So 93 plus 59 plus 65, 217. That is the answer. All right. So now, so now you you can get some idea about the solution by using the constraints. So n is less than equals to 500. So maybe like an n square or some n into something can pass. So what is the brute force way of doing this? Brute force way of doing this, like you create two variables, which is weight of head and weight of body. All right, and then you iterate over all possible indices and then try to map things over. So a solution of this way, I don't want to go to this. Like a brute force solution would be like you create a int f, and then you have some index, and let's declare a vector of int vector of int ARR, and you have some index with which you are moving forward. This will always be one always. So and then you have some int weight of head, and then you have int weight of body. So for you can move forward with like int adding to head, which would be equals to f of index plus 1, and then you add weight plus AR of index of 0, and then weight of body will remain as it is. And then in this you will add like your score. uh, you what you will add is add AR of index of 1, and then you add to body is equals to f of index plus 1 plus wh comma wb plus AR of index of 0, and then here you will add plus AR of index of 2, because now you are adding some body part. In the end, what you need to check is if weight of head is less than equals to weight of body, then return 0, and then this is will if and also if index is equals to n, and you have done this. Otherwise you need to return some very negative number. So some we can do this with arrow size. Just we can do minus in the max for, let's see, and then over here you can be like return max of add head comma add body. So this is like the very brute force solution. All right, now we can optimize this using some DP, and but still the constraints would fail because you have here n as some 500, right? And then 500 into 500 divided by 2, this is the maximum weight of head that we can get, and then we have weight of body, which is 500 into 500 by 2, which is again the max which is again the max weight of body that we can get. Now the other way of doing this is that you just that I do not care about the diff, like I do not have to monetarily create weight of head and weight of body. In the end, what I just want is if weight of head, the weight of body minus weight of head must be greater than equals to 0. All right, then the condition is justified. So what we can do is like there is a set of problems of DP which is known as like the I think difference DPs or some, yeah, I think difference DP or something, in which the states are basically like if you can have such a state, like instead of if you need someone and some two, but you're I'm almost sure that someone plus some 2 is equals to w that is being given to you, then the one of the state is already being reduced, because if you add something to someone, then the other state becomes w minus sum 2. All right, and someone plus sum 2 is equals to w, so that means this can be just some w minus sum 1, and then this becomes like the sum 2 minus sum 1 will just become w minus 2 sum 1. So this is the difference. So this must be greater than or equals to 0. If it is 0, then our condition is satisfied, and then we can move forward with it. So instead of going to a recursive approach, I will show you the iterative code for this directly, uh, because that part is easier to code as compared to the recursive portion. I tried recursive in the, but it failed. Okay, yeah. So basically, I have taken a tuple. Tuple is a struct that I have defined to just make the input easier. Then I'm taking the input, and then I have defined some very negative value, which will be used later. Then I have also defined negative infinity as something, like all. And then what you need is a offset. I will tell you why do we need this offset. So basically, what this means is, uh, like the condition of sum 1 and w minus sum 1, which is sum 2. So what this means is, like, what if all values are in, what if um, w minus 2 sum 1, right? This is what we are looking at. This is the difference portion, and this must be greater than equals to 0. So now if sum 1 is equal to w, then this becomes minus w. And what is w? It is the sum of all wi for n, right? So now I cannot have this in a dp of this, like diff. Why? Because if I have a dp of diff, then as soon as it becomes negative, then it will go memory limit exceeded, because it is going out of bounds. So what I need is an offset, so that it converts these values into positive. So now I know that the maximum difference that I can get is minus diff. So I just have a offset which is plus 2, mm, plus 2 diff, let's say. All right, this is the offset that I'm taking. So now this becomes difference, and the maximum this value can get is w is equals to sum 1. And now you can add offset, which is again twice of someone, so that will go to 3 someone. This is not needed. All that the difference portion will be from someone less than equals to someone. Right. This is the difference portion. All right. So, okay. Hmm. So let me explain the solution. So now I am taking a DPR, and which I have initialized it to minus negative infinity. Now DP of offset, which is twice of sum, is 0. Now you move forward. So basically what you can do is, now basically what you can do is, like, j is equals to minus of sum, and j is less than equals to sum, and do a j plus plus. All right. Now j is basically the difference portion, which is w minus 2 twice of sum 1. Now what I need to do is, like, in the new dp, so now I'll have some weight, and so if difference plus w, so that means that I'm adding it into head, is less than or equals to sum. So that means it won't fall out of bounds. This is the condition check. Then what I can do is, like, if then new dp of this value, like the new weight of head should be equal, will be max of new this, and plus weight of the. So now what here I'm doing, I'm just checking if the difference plus w is less than equals to sum. If it is not falling out of bound. All right. So that I'm checking. If it is true, then new dp of j plus w plus offset is equals to max of new dp of j plus w plus offset, and then dp of j plus offset. Basically, this portion is basically a memory optimization. What I could have is a dp of I, comma something, and over here, instead of doing this, I could have done maybe dp of I, comma sum of head would be equals to dp of I minus 1, comma sum of dp of I, comma sum of head, and comma dp of I minus max of this sum of head, and which is the difference portion over here again, diff plus offset, and plus the weight of head. All right. And then similar for dp of I, comma sum of body, that would be equal to dp of I, comma sum of body and comma dp of I minus 1 comma div plus offset plus the plus b, which is like the sum of width. Uh, over here also, right. So this is the new. So yeah, and then for each, and then you can just calculate for what is the answer when for n, and when for each dp that you have been calculating on for each I plus offset that you need to see, and then print the answer. So I hope this would have made sense to you. It took me a while to get to this solution, but yeah, this is a new concept. I think what happened. Let me tell you. Okay, I'm not sure. I am unable to show the editorial, but this is some difference error technique only. Difference GP technique. So let's move on to the last task which I have been able to solve. I was unable to solve the F portion. We'll figure out a way how to do it later. I don't think I'll be able to figure out it's some mathematical concept of direct proofing. So F part I am not able to do. Okay. Hmm. So this was a like the major problem with this question was just the implementation portion. Other than that, it is a simple problem on 0 1 DFS. Sorry, 0 1 BFS. So you have been given a grid, and you know that uh, Takashi is over here, and he has to reach over here. In that between, you have been placing some mirrors, and light he will shine from here. So he's a flashlight, and he's shining from the left side of the cell towards the right. Assume that flashlights does not diffuse and is a light ray that travels straight. Takashi's goal is to deliver the flashlights to Aoki by using the mirrors in the grid. Where is Aoki now? Uh, on the right side of H, W. So basically, he's over here and Aoki is over here. Actually, he's outside of here, so he's over here. We need to flash a light so that it reaches to him. Now, this and each then you have some mirrors. So like if A is there, then no mirror is placed, so light will travel in this direction only. If B is there, then light will not light. If light is moving from here, it will move downwards. If mirror is such type of place, it will moving here. Then there are some conditions of how a mirror is placed and then where the light is actually going. So if it is going over here, then it will move downwards. If it is coming from top, it will move towards left, and so on. So basically, this will boil down to, matlab, uh, what you do in a simple grid-based problem of 0 1 BFS. You will so what you need to do is like you need to did and so there are some operations that he can perform. So like let's say that he's at some grid and it has a mirror. He can change it to like a mirror having this or having or having no mirror, and then move forward with this. All right, and okay. So I think let me code it by and try to explain to you. So you will take a vector of string of grid. You will have int n comma m as variables, and then basically what you need is like the first of all the direction changes which happen normally, which happens in this case. So that would be 1 comma 0. You can go towards right. You can go to the top. You can move left, or you can go up. Sorry, so this is from 0 comma minus 1. All right. And now also I need so the thing is that if he's let's say I will keep a track of whatever I'm pushing. So I'll just maintain a queue of vector of int q, and I know the starting and the ending points, and I also need some distance array for like if I'm moving from this cell to this cell, then what happens? Now basically what you need to check is if I'm going from right and I am at a mirror which is B, then I will move downwards. If I'm at C and the going towards left, I will move upwards. All right. So then you will need some sort of a vector of. So then you need some sort of a direction. All right. So this will be 3 comma 4, and then this will be if it is if you are at mirror A, then your normal direction will move. If you are at mirror B, then you see if you are going towards left, then it takes you to the uh, then it takes so let's assume so this is string str is equals to string moves is equals to so this is right down, this is left, and this is up. All right. So if we am for B now, what will be swapped is right. If I'm going towards the right in for B, which is mirror of B is mirror of this type. If I'm going towards right, it moves me towards downwards. So whatever was right will now become so this is 1 comma 0, and whatever was left will become up, and whatever is up will come left. Now for C, what will happen is if I'm moving towards right, it will send me upwards. So right को up से place कर देना है, so we'll repeat right with up and down with left. So this is 3 comma, and then you have to replace uh, comma, and then this is 0, and then this will become 2, and then this will become 1 comma 0. All right. And then you can just iterate over q and then keep checking for the distance. If while telling this is very this is sounding very simple, but if you actually go down to implementing it, the implementation part is pretty complex. So now let's look at the results. It took me a while as well. So this is again the mapping of the direction that I had taken, and then the grid input. Now what you actually need to see is that you cannot that while doing a BFS, what you input is I comma j. But here in this case you cannot do that. You also need to check what was the direction in which I was moving. So first I was moving in right direction, so that I have taken as 0. All right, and distance of 0 comma 0 and in the direction of right will be 0. For left and right and other things I cannot be sure. Why? Because assume that you have some arrangement like 0 comma 0 and you have to reach here top. So there must be some mirror over here, then you have to fall back, and some mirror over here, then some mirror over here, and then this part. So number of mirror changes to actually reach to this part will be some x. All right, and then that part is unknown to us. So just assume कि while क्योंकि इसमें it has been given that Takashi is pointing out the right towards right. So 0 comma 0 comma 0 is equal to 0, this distance. Now you just maintain a DQ. This is a problem of 0 1 BFS basically. Now the why 0 1 BFS? If I am changing the mirror, okay, let me explain my code. So you push into the queue I comma j comma direction. So first you pushed I comma j comma 0, and then you are like int x equals to first element, which is like you get x out of it, you get y out of it, and you get a direction out of it. And then you need to check the mirror. What is the current mirror that I am on? If I am on okay, and then what you need to check, see is like, do I need to change this mirror or not? So what you will do is like iterate over all types of possible mirror. So A, B, and C, let's mark them as 0, 1, and 2. And then if the new mirror is equals to the mirror itself, then cost of mirror will be 0, otherwise cost of mirror will be 1. Now in new x will be equals to x plus moves of x plus, now you get need to visit a direction. All right. How do you get direction? The direction will be mirror. Uh, this is a mapping of mirror and the normal direction in which would have moved. All right. So for A it is 0, 1, 2, 3, like move right, move down, move left, and move top. It will change to move up and down respectively for B and C. All right. This mapping, once you have maintained, then what you need to do is in cost equal. Yeah. So this is just a condition check that if x equal to n minus 1 and y is equal to m minus 1, and then new direction is equals to 0. Why? Because we need to make sure that the light is exiting on the right side itself, not anywhere else. If it is exiting on top, if it is exiting towards bottom, uh, then it is not possible. If it only this condition, because Ayoki is standing over here, all right. And so if this is true and then it is moving towards the right, the new direction, then answer is equal to distance of this plus cost. All right. Cost is basically if it is a whole mirror, mirror are same or not. All right. And now for the new mirror, all we have to do is like if the distance of new x and new direction is greater than equals to new, if the like the distance after you have performed an operation and you haven't visited that cell, so you will need to update that. So just update it, and now just make sure if cost is 1, I will push it to the back because I don't want it to have like the cost 1. Otherwise, I'll push it to the front. I think this part could have been optimized if I would have just used a priority queue. Let's see, over here, priority queue and q dot push, and then q dot uh, top, q dot pop. If you the priority queue, then this becomes, and now I'm just pushing item 2. This is 1, 2, and then this is 0. And instead of pushing this, I can just push uh, this UBR. Right. Actually, you know, then I need to also like uh, matlab I would also have to like if I'm because what is the priority that is being given, so that is the cost element, so I cannot do that. I need to have another like index which will be the cost for the priority queue. Basically what is the priority that you need to give that portion. All right, so now I think the solution becomes clear, and in the end just print the answer. So yeah, the part which I was talking about, so q dot push back. So if the cost is 0, then I would need key. Then there is a greater chance of कि मतलब, of having smaller element in the front and weaker element in the back. So for that I would have just maintain a cost and then have a priority key. But this part also works. It will like make sure that the heavier elements are at the back so that I don't I draw to the heavier elements first. Yeah. Mhm. So this was it. I haven't able to do the F or G problem. I haven't actually even seen what is the F problem, and yeah. So that is it for today's review.